In every chemical reaction, it's the atoms and molecules of the reactants that are getting rearranged to give us new products. And this rearrangement could happen in many ways. Like for example here, the atoms and molecules are combining to give me one single product. Or you can have a big molecule that breaks down into smaller molecules. Or you can have an exchange of atoms between the reactants to give us new products. So depending on the ways of rearrangement, we can classify chemical reactions into various types. And in this video, we are going to talk about two of those types: combination and decomposition reactions. Now, before I define them for you, let me give you some examples. So here I have some examples of one of these reactions. Now, can you pause the video and figure out what is the common way in which the reactants are rearranging to form the products? Pause the video and try it yourself. Okay, now if you have tried, let's see. Over here, in every example I can see the reactants are combining to give me one single product. Here also, two reactants are combining to give me one single product. Everywhere you can see the same thing is happening. So these are the example of combination reaction. Combination reaction. At a molecular level, if you see, the atoms and molecules of the reactants are combining to give me one single molecule, one single product. So I can say that in combination reaction, multiple reactants combine together to form one single product. And if I have to write the general structure of these reactions, it looks something like this. A plus B gives me AB. Whereas it could even be, 3 reactants or 4 reactants, A plus B plus C plus D, any number of reactants, they all combine to give one single product. That is an example of combination reaction. Now, decomposition reaction, that is totally opposite of combination reaction. See, in combination, multiple reactants combine to give me one single product. Whereas in decomposition, one single reactant breaks down, decomposes into multiple products. Look at some examples here. Here I have iron sulfate. This is breaking down into iron oxide, sulfur dioxide and sulfur trioxide. One single reactant is breaking down into multiple products. Similarly, here calcium carbonate is breaking down. Here lead nitrate is decomposing, right? At a molecular level, something like this is happening. A big molecule is breaking down into multiple products. And if I have to write down the general structure, it looks something like this. AB breaks down into A plus B. Or, something like this is also true. ABC is breaking down to A plus BC. The main idea is that there will be only one reactant and that will be breaking down or decomposing into several products. The products could be anything. So now that you know what is combination and decomposition and you understand the basic difference in their definition, let's look at the examples of combination into much more detail. So here I have a magnesium ribbon and I'm going to burn it. Now you can see that it burns with a dazzling white flame. In fact, there's a lot of light and heat energy given out. And after the reaction, we are left with a white powder. And this whole reaction is an example of combination reaction. Let me write down this equation and you'll be able to understand it better. So here we have magnesium to begin with, Mg, and it is reacting with oxygen. See, whenever something burns in air, right, it reacts with the oxygen that is present in the air. So it is reacting with oxygen. And finally we get, since this is a combination reaction, these are going to combine and we will get one single product, which is magnesium oxide. MgO is the formula of magnesium oxide. Let me quickly balance this equation. Here we have 2 oxygen. So here I'm going to put a 2 here. And since this is 2 Mg, I'll need to put a 2 over here also. Yes. So you can see that here magnesium combines with oxygen to give us magnesium oxide. This is the white powder that is being left out. And in this process, a lot of heat is being given out also. Now let's look at another example. Burning of coal. Now this is also an example of combination reaction. Here the carbon present in the coal, when it burns with the air, right, it combines with the oxygen in the air. And finally we get carbon dioxide. And this is also giving out a lot of light and heat energy. Let's write down its chemical equation. So here I have carbon that is present in the coal. It reacts with the oxygen of the air. And finally we get carbon dioxide. These both combine to give me carbon dioxide. And this is a combination reaction. And in this one also a lot of heat is being generated. Now let's look at another example. I have a white powder. This is calcium oxide. Now when I pour some water on top of it, so water is going to combine with the calcium oxide. and we will get a white milky mixture which is used to whitewash our walls. We'll talk about that later, but let's write down this equation and see what is the combination reaction. So here I have this white powder which is calcium oxide, and this is going to react with the water. I am adding water onto it, H2O, and these both are going to combine, and finally I'm going to get calcium hydroxide. The formula of calcium hydroxide is calcium and hydroxide is OH whole twice, and this is balanced: 2 oxygen, 2 hydrogen, 2 oxygen, 2 hydrogen, 1 calcium. Yes. And in this reaction also, if you touch the container in which this reaction is happening, you will feel that it is getting warmer. So in this one also, a lot of heat energy is given out. So now we have looked at many examples of combination reaction. Here, multiple reactants combine to give me one single product. And we also saw that in all of these reactions, energy was given out. And such reactions are called exothermic reaction. And in general, combination reactions are exothermic in nature, meaning they give out heat. But not all combination reactions are exothermic. There are some exceptions, such as when nitrogen combines with oxygen and forms nitrogen oxide. In this reaction, a lot of heat needs to be given in. So this is an endothermic reaction. But we'll talk a lot about energy given out or energy required in a separate video called exothermic and endothermic reactions. Over here, let's now talk about some common examples of decomposition reaction. So first I have some light green colored crystals of iron sulfate, and I'm going to heat them. Now as I heat them, I see the color changing from light green to brownish color. And also there is a bad smell coming from here. So this tells me that there is some chemical reaction that has taken place. In fact, iron sulfate has decomposed into multiple products. Let's write this equation to see this. So I started with having iron sulfate, FeSO4. That is the chemical formula of iron sulfate. Now when I heat it, I am going to heat it. Let me write over here heat. Heat is providing energy which is making it break or decompose. So it is decomposing into a brown powder, right? And you can recall that when iron rusts, iron oxide is formed, and that is also brown in color. So here also we are getting iron oxide, Fe2O3. And plus the foul smell, the bad smell that was coming, right? That is because of sulfur oxide, sulfur dioxide and sulfur trioxide. So here we get sulfur dioxide plus sulfur trioxide. In chemistry, in fact, whenever you have some bad smell coming now, generally it will be something to do with sulfur. So sulfur is the smelly one in chemistry. Okay, let me just quickly balance this. Over here I have 2 iron. So let me just put 2 iron over here. So now I get oxygen is 4 to the 8, 3, 2, 5, 5, 3, 8. Sulfur is 2, sulfur is 2. Yes, so this is the balanced reaction of the decomposition of iron sulfate. And over here, heat energy was required. And generally, heat energy is required because whenever you are trying to pull away the atoms of a molecule, then we need to provide some energy, because there is an attraction between these atoms. So that's why to pull them away, we need to provide some energy. And that's what is happening over here also. We are trying to break it down. We are trying to decompose this big molecule. That's why we need to provide energy over here. But there are many more things that are also happening, and we'll talk about that in detail in exo and endothermic reaction video. Okay. Now let's look at another example. Here I have a spoonful of silver chloride. It is a white powder, and I'm going to leave it under the sunlight. Now after a while, I see that the color has changed. It has become grayish in color. Now this color change tells me that there is some chemical reaction that is going on here. Let's write down its chemical equation to see. So silver chloride is AgCl. And if I leave it under the sun, it is using the energy from sunlight. And it is decomposing into silver and chlorine gas, Cl2. So since Cl is 2, here I'll have to put 2. And since 2 Ag, so here 2 Ag. Now the reaction is balanced. So this is also a decomposition reaction. Here one big molecule is breaking down into 2 smaller molecules. And here it is utilizing the energy from the sunlight. Now let's look at one more example. I have a beaker full of water, and I'm going to insert some conducting rods into it, which are connected to a battery like this. So over here, electricity will start flowing into this circuit. And you will notice that there are some bubbles erupting at the point where these conductors touch the water. There will be some gases being evolved. So what's happening here? So actually here, the electrical energy is breaking down the water and hydrogen and oxygen gases are being evolved. Let's write down their chemical reaction. So here we will see that H2O, water, is decomposing with the help of electrical energy, electricity, and it's decomposing into H2 gas and oxygen gas. Let's balance this equation. Over here there is 2 oxygen, so I'll write 2 over here. Now there is 4 hydrogen, so I'll write 2 over here. So yes, this is the balance equation of water dissociating into hydrogen and oxygen because of electrical energy. So okay, now we have looked at some examples of decomposition reaction. In decomposition reaction, one big reactant breaks down or decomposes into multiple products. And generally, decomposition requires more energy. And such reactions that require more energy are called endothermic reactions. We'll talk about that later. Sometimes we give energy in terms of heat. And these decomposition reactions are given a special name. They are called thermal decomposition reaction because heat is involved over here. And in some reactions, decomposition happens using the energy of sunlight. And these are given a special name. They are called photochemical decomposition reaction. And you might be wondering why photo? Because see, light is said to be made of small packets of energy called photons. And that's where this name photo is coming from. So, okay, this is photochemical decomposition reaction. And in some decompositions, energy from electrical energy is required to initiate this decomposition reaction. And now such reactions are called electrolytic decomposition reaction. So now we have studied a lot about decomposition reaction. Let's now summarize this video. We saw that combination reactions are those in which multiple reactants combine to give me one single product. Whereas decomposition is totally the opposite. Here, one reactant decomposes into multiple products. And we also saw that generally this requires energy because we have to separate atoms, which will require some energy, right? And if this energy is given in form of heat, then it's called thermal decomposition reaction. Whereas if this energy is given in form of light, it will be called as photochemical decomposition reaction. And if the energy is given in form of electricity, then this will be called as electrolytic decomposition reaction.